All right, hello everyone, this is Mr. Crozier. I'm going to go over two more volume problems for you. Here we go, and this falls under notes, lesson 6.2. On problem A here, we're given an equation, which is this straight line, 2x plus 1, and we're just going to talk about this over the interval from 0 to 3. So I went ahead and graphed this. Again, this is going to be a straight line. If I plug in 0, it's 1, so I have a point here at 1. If I plug in 3, I have 7, so there's a point there, and it's a linear equation. And we're going to take this, and we are going to rotate it over this axis. So we're going to take this and drop this straight down, and we're going to make this shape down here. Now, the key to these is to be very careful. So you want to get everything in the right spot. This point is 1 above the axis, so it goes 1 below the axis. This point is 7 above the axis, so it should be 7 below, so down to there. And you want to take your time, use your ruler, graph this out, and there's my shape. And that shape has been spun around this, so it's going to go this way. And I always just draw some curves in here, some circles. And at the end we draw one big circle. But it kind of looks like the end of a trumpet. Kind of looks like a pyramid that's laying on its side, but it's a three-dimensional shape, and it's being spun around this way. So we want to try to draw that to the best of our ability. And again, we always want to put in here the rectangle that we're going to do. I'm going to build rectangles that are this way. And actually, more accurately, I'm going to build circles that are this way, that have this rectangle here. There's a little circle, there's a big circle, and there's this giant circle out here at the very end. So I'm going to do all of those circles in there. So try and make your picture as accurate as you can. You always want to put the way you rotated on it, and you always want to put the rectangle in there. All right, so we don't have a geometric formula for that. I don't know the area or the volume formula for that. So what we do is we say the volume is equal to pi r squared dx. All right, so the volume goes from 0 out to 3. And pi is a constant. I'm going to pull the constant out. And my radius is top function. And in this case, the top function is 2x plus 1. And in this case, the bottom function is 0 because it's going all the way down to the axis. So I don't need to put a minus 0 there. Sometimes you do. If you have something that's not rotated around the axis, you're going to have a top and a bottom. But this just has a top. Top function is right here. Y is equal to 2x plus 1. And the bottom function is right there. Y is equal to 0. All right, so that's all we got to do. And then you get that. Whoops. Pi r squared. All right, now I need to type that in my calculator. I'm going to hit Math 9. I'm going to integrate from 0 to 3 of 2x plus 1 squared dx. I always put it like that. 57. Let's see if we need those extra parentheses in there. 0 to, whoops. Second quit. 0 to... All right, here we go. 0 to 3, 2x plus 1. Yeah, you're going to have to put that second set of parentheses in here, I believe, because you want this thing in here being squared. Dx, again, is 57. Now, again, when you get done, don't forget to write 57 pi. The units are units cubed. But don't forget to put that pi in there. You don't want to integrate with the pi because you'll get a decimal, because the estimated answer is 179, right? You might see it both ways, but we always want to do it the exact way first. All right, one more version of this. If you take a look at problem B here, we're going to do the same thing, same equation, same graph. However, now we're going to revolve it around the y-axis. So now it's going to go this way around this way. So I want to line up this over there. Well, this point's going to stay the same, and this is going to be 3, 7 or negative 3, 7. Go ahead and draw this. And then I go ahead and draw all my circles in there because I'm revolving it this way. All the way through there. Now it looks like a tornado, or it looks like a funnel. And if I draw my rectangle in here, again, right there's that radius. So I'm going to do the same formula. Volume equals, I'm going to integrate, well, let me write this down, pi r squared. Volume equals pi times, now I'm integrating from this point here, which is 1, to this point there, which is 7. So be sure you notice that it's not, on the first problem I was going from 0 to 3 on the x-axis, now I'm going from 1 to 7 on the y-axis. So this is now dy, because I'm drawing my circles in here, and my circles are going across the y-axis. However, we have another problem. This equation right here, this equation that I use is written in terms of x, not y. So I have to solve this for y. I have to subtract this over here. That's y minus 1 is 2x. Divide that over here. And now I have an equation that's in terms of y. So now I can write this in here like this and square it. And that's the equation I'm going to use. If you try and use this one, you'll get the wrong answer because it's dy, so these need to match. The variables need to match. All right, let's see if we can get that in our calculator right here. Math 9, 1 to 7 of parentheses. I think we're gonna need 2 sets of parentheses. Well, why don't I just do it this way? Now I'm gonna go ahead and I'll go ahead and use the x button. X divided by 2 minus 1 divided by 2 squared dx. Now I'm using the x button, which is fine. As long as all of these variables match, it doesn't matter what I type in my calculator. These are right. I could use any letters I want to right there, but I'm going to use those ones. And then I come up with 18. Let me make sure I've typed that in correctly. Let's see what this volume is here. We have Math 9, 1 to 7, and the equation is x divided by 2 minus 1 divided by 2, parentheses, square that whole thing, and then put an x there. And we have 18. So the answer is 18 pi units cubed. Just don't forget to change this variable around right here. You need to make sure you change it, or else you're going to get the wrong answer when you go to do that. All right, hope this helps. The key is make sure you draw a good picture so you know exactly what you are measuring.